We've been asked to rationalize the denominator on some different expressions, and so we're going to do these. There's 3 of them total. We're going to start with the top one and work our way down. The first one's very simple. Rationalize the denominator, 5 over square root of 3. Well, the easiest way to get rid of a radical is to multiply it by itself if it's a square root. And so if I multiply the square root of 3 times the square root of 3, whenever you multiply the bottom of a fraction by something, you have to multiply the top of a fraction by something so that you don't change the problem. What is the square root of 3 times the square root of 3? Well, there's 2 ways to do this. You can think of the square root of 3 times the square root of 3 as the square root of 3 squared, right? Because x times x is x squared. Or you can say, well, 3 times 3 is 9, so this is the square root of 9. Now, either way you write this, the square root of 9 is 3, or the square root of 3 squared, these cancel, and the answer is still 3. So either way, what this is going to become, square root of 3 times square root of 3, is going to give you as a denominator 3. What about the top? What about the numerator? What is 5 times the square root of 3? Well, this one's under a radical and this one's not. I can't combine them. So I just write 5 times the square root of 3. Very much like if I had 5 times x, I would just write 5x. And a lot of people aren't real comfortable with this. They say, well, why did you do that? Well, the rule is very simple, that we need to rationalize our denominators. We don't want radicals in the bottom of a fraction. And so if this denominator has been rationalized, we can say that we're done. This is as simple as it gets. And even though this actually looks more complicated than this is considered the simplified form because there's no radical in the denominator. Okay, so I know it seems kind of odd, but that is our simplified form. So let's move on to something a little more complicated. What if instead of a single radical, now you have a binomial type expression in the denominator? 2 divided by 3 plus square root of 2. Well, whenever we want to get rid of a radical that's part of a binomial, we have to multiply by the conjugate. And the conjugate of any radical expression is keep this part, okay, change the sign, and then keep this part, okay? So in other words, if it's 3 plus square root of 2, the conjugate's 3 minus the square root of 2. If this was 3 minus the square root of 2, the conjugate would be 3 plus the square root of 2, okay? If you multiply the bottom by that, you have to multiply the top by that. And of course, the way this works is real simple. The top, because this is a binomial, this is treated like a binomial, is going to be distributed. So we're going to say 2 times 3 and then 2 times. All right, well, that's real easy. 2 times 3 is 6. 2 times the square root of 2 is 2 square root 2. Okay, that seems pretty simple. How about here? Well, I said to treat this like a binomial, so you're going to multiply it just like a binomial. Some of you would say, well, we'll use the FOIL method. Well, that's fine. So you're going to say 3 times 3 is 9. 3 times negative square root of 2 is negative 3 root 2. Root 2 times 3 is plus 3 root 2. And last but certainly not least, square root of 2 times negative square root of 2 is negative square root of 4. And a couple things you'll notice. Negative 3 root 2 plus 3 root 2, what happens? They cancel. And the point is we want to get rid of the radical in the denominator. And so if these don't cancel, you'll have a radical in the denominator, and you've obviously done something wrong. How about here? Well, what's the square root of 4? This is 2. So really, in the denominator, we end up with 9 minus 2. Well, what is 9 minus 2? 7. Oh, well, that's pretty easy. And then the top pretty much remains unchanged, would be 6 minus 2 root 2. Or you could factor, 2 will go into both of these, and so you could write this as 2 times 3 minus root 2, which is actually, what you had originally. The reason we would factor this 2 back out is if this came out to be an even number, then we could simplify. Okay, so it's a good habit to always try and factor that out. So there's our final answer there, 2 times 3 minus root 2 over 7. Okay? So now what if we make this a little more complicated and we have a radical type binomial on top and a binomial with a radical on the bottom? What do we do here? Well, again, the goal is to get the radical off of the bottom. And so we're going to multiply by the conjugate of the denominator. So we're going to multiply top and bottom by 5 plus root 3. 5 plus root 3. Okay. And 5 times 5 is 25. 5 times positive root 3 is 5 root 3. Negative root 3 times 5 is negative 5 root 3. And those will cancel. And then negative root 3 times positive root 3 will be minus square root of 9, which is just 3. So the bottom is the denominator is 25 over 3. How about the top? Well, 7 times 5 is 35. 7 times root 3 is 7 root 3. I'm going to need to extend this. Root 2 times 5 is 5 root 2. And root 2 times root 3 is root 6. And unfortunately, what happens here a lot of times when you have a radical on top and a radical on bottom, when you have this type of expression, is this, and this are not like terms. We can't combine them. So we end up with this really ugly numerator. So let's simplify. Well, 25 minus 3 is 22. At least the denominator is easy. And then we have 35, 7, 5, and 1. So we have 35 plus 7 root 3 plus 5 root 2 plus root 6. And none of these will simplify, and so that would actually be our solution. Okay? So that's how we rationalize the denominator. And I know a lot of you are looking at this saying, well, isn't that more complicated than what you started with? Well, it kind of is, but there's no radical in the denominator, and that was the goal. So if you have any questions about this, please come see me.